Hello, good morning everyone. I'm Aniket Mishra. I have done Emertxe IoT based home automation internship from Emertxe. I am a student of CMRIT Bangalore, and here's my project profile to share my experience of how the Emertxe internship was. Now the contents of the internship. What is IoT? How does IoT work? What are embedded systems? C and C++ languages. And we'll see about Arduino IDE, PIC Sim Lab, and Blink IoT app, null emulation, home automation, and functioning. This internship was a 5-week long internship based on the creation of a home automation tool, which was made using IoT based IDEs and tools, including Arduino IDE to code the project necessities, and the Blink IoT application as a cloud platform, a PIC Sim Lab tool to stimulate the Arduino hardware. The internship was a complete process of small steps essential to get a final outcome, which wouldn't have been possible to if we without the guidance of teachers and if you wouldn't have attended the classes of internship. Now, what is IoT? What IoT brings internet connectivity, data processing, and analytics to the world of physical objects. For consumers, this means interacting with the global information network without the intermediary of a keyboard and a screen. An example for this can be Alexa. In enterprise settings, IoT can bring the same efficiencies to manufacturing processes and distribution systems that the internet has long delivered knowledge work. Billions of embedded system internet enabled sensors worldwide provide an incredibly rich set of data that companies use and can improve the safety of their operation, track assets, and reduce manual processes. And data from these machines can be used to predict whether the equipment will break down, giving manufacturing advancing warnings to prevent long stretches of downtime. Researchers can also use IoT devices to gather data about the customer preferences and behavior, although that can have serious implications for privacy and security. Now we'll see how the IoT works. The first element of a IoT system is a device that gathers data. Broadly speaking, these are internet connected devices which have an IP address. The range in complexity from autonomous mobile robots and forklifts that move products around factory floors and warehouses to simple sensors that monitor the temperature or scans for gas leaks in buildings. Examples are like fire sensors in buildings and offices. They also include personal devices such as fitness trackers that monitor the number of steps of individual take each day. Now the next step of IoT process is the collected data is transformed from the devices to a gathering point. Moving the data can be done wirelessly using a range of technology over wired networks. Data can be sent over the internet to data center or the cloud, or the data can be performed in phases with intermediary devices aggregating the data, formatting it, filtering it, and discarding the irrelevant or duplicate data. Now the final step of data is data processing and analytics and can take place in data centers or clouds. But sometimes that's not an option because in case of critical devices such as shut-offs in industrial settings, the delay of sending data to a device can be very large. Now, what are embedded systems? An embedded system is a combination of computer hardware and software designed for a specific function. Embedded system may also function within a larger system. These systems can be programmable or have fixed functionality. Examples are industrial machines, consumer electronics, agriculture and processing industry devices, automobiles, medical equipment, cameras, digital watches, household appliances, airplanes, vending machine and toys, and as well as the mobile devices are possible locations for an embedded system. C and C++ language. Some of the few basics covered in we'll see are what we learned in C and C++ languages were basic syntax and data types, what are operators and arrays. We learned about functions and pointers. We learned about preprocessor directives like header file and macros. We learned about the storage classes, strings. Some of the very basics were covered from C++ language, and they were basic syntax, classes and objects, and constructors and destructors. Now about the Arduino IDE. Arduino IDE is an official software introduced for compiling and uploading the data to an IoT cloud. It is an open source software and is easily available to download and install from Arduino's official site. Arduino's IoT cloud is a service that allows you to configure, program and deploy your Arduino devices. It is an all-in-one solution for IoT development where you can build visual dashboards to monitor and control your devices, integrate and other services, and much more. This article summarizes the use of Arduino Cloud IoT and includes information regarding requirements, installation, API and general use of the platform. Now about the PICSIM Lab. It is a real-time emulator of development boards with MPLABX debugger integration. It supports microcontrollers from PICSIM, SIM-AVR, UCSIM, KEMU STM32, KEMU ESP32 and GPSIM. PICSIM Lab has integration with MPLAB and Arduino IDE for programming the microcontrollers board. As purpose of the PICSIM Lab is to emulate real hardware, it does not have any source code writing support. For code writing and debugging, the same tool is used for real board and should be used with PICSIM Labs such as MPLABX, Arduino IDE or VS Code and Platform IO. PICSIM Labs supports several devices that can be connected to the boards for simulation, such as example LEDs and push buttons for and inputs for some complex ones like the Ethernet shield, internet connection and color graphic display, and touchscreen are the complete list of parts accessed in the documentation. Now we'll see about the Blink IoT app. Blink is an IoT app for iOS and Android smartphone that is used to control Arduino, Raspberry Pi and Node MCU via the internet. This application is used to create a graphical interface or human-machine interface by compiling and providing the appropriate address on the available widgets. Now what is home automation? Home automation is a technological solution that enables automating the bulk of electrical and technology based tasks within a home. A home with an automation system is also known as a smart home. Like nowadays we see in Google Home, Alexa Home. We can control lights, fan, everything with one device. Now controlling of home application automatically or remotely. We can control fan, light, AC, door, etc. both automatically and remotely. We are using IoT for the communication. It is going on in additionally incorporates domestic security such as access management and alarm system. Once it is coupled with the internet, domestic gadgets are very important constituent of the Internet of Things. The program for control of system makes use of both wall-mounted terminals, tablet and desktop computers. A smartphone application or an online interface that may be even approachable off-site through the internet. Now these are the screenshots of from the Blink IoT app for our project. The first screenshot says that it is for the Blink cooler and heater, and here if the temperature is greater than 35.56 degree, we will get a notification that the cooler is turned off. Now for the second one, it is for the water level indicator. If the water level is less than 2000 liter, we will get a notification that the flow is enabled and the valve has been closed. The third one is which shows the current volume of the tank and the temperature of the tank, and also gives information if the inlet valve is closed or the inlet valve and outlet valve, if it's closed or it's on. Now about the project units. The project units are PIC Sim Lab Real-Time Simulator, LDR Temperature Sensor LED, LCD HDR 44780, 10 PCF 8574, and ETH W5500. As we can see in this diagram, these are the components in our project. And this is the PIC Sim Lab Arduino for the it shows the representation of the PIC Sim Lab real-time emulator, and also shows the megahertz frequency for the same. Now the spare parts and tools used in a project are LDR temperature sensor, temperature system, LED, LCD, HDR 44780, 10 PCF, PCF 8574, ETH W5500, and serial remote tank. Now talking about the Disha workshop, which was part of our internship schedule also, we were taught how to make resume. We were taught how to be confident, what fields to focus on, and how the IoT is the future and is the king in the future market, and will be a great force for all our developments for the projects and everything. Now, for the vote of thanks, I would like to thank all the teachers involved in this internship for teaching us all the important factors involved in IoT internship. A special thanks to Emertxe for giving me this opportunity to be part of this internship. Thank you so much.